stands for imaginary. Very good. So an imaginary number, right, is when you take the square root of a negative. It's the square root of a negative. Yeah. Okay. So very important to know that I is the square root of -1. Right? Because anything has a factor of 1, so any negative number has a factor of -1, so you take the square root of it, it becomes imaginary. Woo! Yay? So, for example, when you're solving a square root of a negative number on your calculator, say because your calculator doesn't do imaginary numbers, but you can. All you have to do is pull out an I. It sounds very Babylonian. No, you just pull out the imaginary part, which is the square root of -1, and it just becomes I root whatever, I root x, right? Don't forget the plus or minus. Okay, here we go. So, for example, the square root of -5. You can pull out the -1 and separate that from the 5 in the square root. -1 is, square root of -1 is I. So this is plus or minus I root 5. Woo!
So the square root of the negative number will always be I? Or
yes! There's an I in there. There's an imaginary number there. I is the square root of -1. True? Yes? Okay. 81. What's the square root of 81? 9. So if there's a negative there, 9I. We just put the I at the end because treat it like a variable because it's a letter. So if you have a perfect square, this is plus or minus 9I. That's it. It's a perfect square. If it's not, just leave the radical there. You may or may not have to simplify the radical. That's why I spent so much time on it. All right.
Wait,
Yeah. 9I, usually put the number and then the variable next, which it's not a variable, but it's a letter. Yeah? All right. This is how we get to I squared. Because if you put root beer in a square glass, you get beer. So when you square the square root of -1, you get -1. Well, you might want beer. I don't know. Here we go. I squared is -1. That's the number of the day. Is -1. Anytime you see an I squared, it changes from an imaginary number to a real number. Yeah, squaring the imaginary number turns it from imaginary to real. Okay, here we go. The powers of I. So if first I is I, then I squared is -1. I to the third would be -1 times I, which is -I. Then I to the fourth would be -1 times -1, which would be 1, right? So that pattern keeps going on. It goes I, -1, -I, 1, and it keeps on going, right? Here we go. You can figure out how to do this by hand, and I'm going to show you by hand. I'm going to show you by calculator, okay? First by hand. If the number is even, just divide that by 2. What's 12 divided by 2? 6. So would you agree this is I to the second power? So there's the I squared to the 6th. And I squared is -1. What's -1 to the 6th power? It's 1. Right? Because there's an even number of positives, so this would just be 1. Okay? 17. Can't divide it by 2, so you need to pull out an I. So this would be I times I to the 16. Do you believe? Yay? Okay. Keep the I there. Isn't I to the 16 I squared to the 8? Right? And I squared is -1 to the 8th is 1. So I times 1 is just I. That's it. Okay? So that's how you do it by hand. I spent a lot of time in this in regular too. Let's just make the most of this and take a look at our calculator. Right? Oh, up, go back. There you go. Sorry. Here we go. All right. If you get this question on the SOL, you're not spending that much time in it because there's a way to do this in your calculator. Here we go. I see the questions in your eyes. Here we go. If you hit math, yeah, go over to num. because I know some of you are feeling numb after yesterday. And go to IPART, not IFART, but IPART. There it is, right? And the I is on the decimal. See where the decimal is? There's a little blue I there. So you could just do I to the 17, like this. Oops, delete. Literally type it in your calculator like that. Oops, second enter. Math, num, IPART, I to the 17. It's I. Joy. Yeah? Okay. So calculator does it for you. No big deal. Got it? Okay. Yeah. Yeah. Okay. So let's go on to more serious things. Here we go. A plus bi is called a complex number. Repeat after me. Complex number. Complex. Yeah. It's complex because it has both a real and an imaginary number in it. Yeah? The A is the real number, so usually we'll put the real number in the front and then the imaginary at the end. So the imaginary part is B because it's next to the I. It's being multiplied by an imaginary number. Okay, so here we go. When you multiply, you just multiply like normal. So what's 8i times 3i? 24i squared, and I squared is -1. So anytime you see something to I squared, if it's a positive 24, 20i squared, it's -24 as a real number. Yeah. Yeah. Okay. Okay. Here we go. For the next one, you can't do math unless you have the imaginary numbers separated. Okay, so don't try to multiply the -5 times the 20. It's not going to work because it's not a real number just yet, right? You can only multiply real numbers together. So for this one, we pull out the I. Remember, this thing is just plus or minus I root 5 times root 20. Okay? Now multiply the 5 times 20. 100. And what's square root of 100? 10. So this is plus or minus. Yay! Am I going too fast, too slow, or just right?
I'm starting.
Yes, love. Yeah. I part.
So
And then
when you said the I, so like alpha.
not alpha. No. Just hit the blue button and then hit period. Yeah. Second period is the I. Yeah? All right. Perfect. Okay. Yes, love. Where did 100 come from? 5 times 20. Right? Yeah. No worries. Anything else? Okay. This whole front page is the baby stuff to get to the back page. Okay. All right. Here we go. Woo!
Oh.
Okay. Now, numbers 7, 8, 9. Right? Isn't that a joke? Why 6, 3, 7? Anyway, numbers 7, 8, 9 can be done using, you cannot factor them, right? But you could use the quadratic formula or completing the square if you'd like. But there's an easier way. There's an easier way. Since it's equal to 0, we have just x squared equals 8 plus 81 equals 0. If you move the 81 to the other side, then you're going to get x equals -81. X squared equals -81. You see? Yeah. Then, when you take the square root of both sides, you get x equals plus or minus the square. Here we go. X equals plus or minus the square root of -81. And we know what the square root of -81 is. 9i. Right. So x equals plus or minus 9i. Yeah. Oh, this is so good. So good. Okay. Here we go. Again, if it's just one variable, let's move it to the other side. So x squared equals -72. So x is equal to plus or minus the square root of -72. Okay, calculator. Here we go. Let's practice again. We know we're going to pull the I out, which is fine, but what else comes out? So, you know it already. 6 and 2. Yeah. If you don't know, go to your calculator, hit y equals. Oh, yeah. There it is. Go to y equals, and then we're doing 72 divided by Hello? X squared second table. Right? And if you take a look, oh, P.S. See right here where it says 3 and 8? Some of you did that to me on the quiz. Keep going down. Right? 2 is the smallest y. 8 could be broken up some more. So 2 is the smallest y, so it's 6 and 2. Okay? So, x is equal to plus or minus. Yes! There it is. Yeah. Number, I, and then the square root. Good times. Good times. Pull out an I. Yes. All right. Here we go. Yeah. Good. Okay. Maybe 9 wasn't it? Was 9 1? I don't know. Oh, never mind. 9 and 10. Those are easy. Sure they are. Okay. Here we go. In 9 and 10, you're just adding and subtracting. Addition is pretty good because you don't change any signs. When you add or subtract, you add reals to reals, imaginary to imaginary. So in number 9, what are the reals? 8, negative 12. 8 plus negative 12 is? Negative 4, right? And then 7i and 11i are the imaginary. 7 plus 11, 18. So plus 18i. Ta-da! Ta-da! Yeah. 10 is easy when it's sum. 9 is easy with sum. Number 10, put a star next to it. Because it's just as easy with one little twist. Ah, very good. Make sure you distribute the negative. Yeah. Once you distribute negative, you can get rid of the parentheses. So it's just 9 minus 6i minus 12 minus 2i. So a lot of the mistake would be if people would add the 2i to the negative 6i, and that's not right. Yeah? The reals are, which is, A2Trig. Negative 6 and negative 2. Ta-da! A plus bi. This sweet? Okay. Let's multiply. Yeah. It sounds like a terrible pickup line. Here we go. What's up? Yes! Yes. Let's multiply. No, never mind. There we go. All right. Here we go. The question for Miss Adrian was, can you multiply an imaginary to a real? The answer is yes. Yes, you can. All right. So this is just normal distribution. Just keep a track of, like, if you have to multiply an I to another I, it's I squared. Okay. Here we go. So negative 5i to 8 would be good. Negative 5 to negative 9. Plus 45 I squared. Yes, Barnum. Yes, there it is. So negative 40I stays as it is, but I squared is negative 1, so this becomes negative 45. True? Now change it in the form that I like, real plus imaginary. How's it go? Yep. Yep. There you go. If you forget to do that, no big deal. Just so you know, on the SOL, they put real plus imaginary. Yeah? Yeah. Good old I squareds. Yeah. Let's try chicken. All right. Yeah. Here we go. Seriously? Here we go. 8 times 2. 16. Minus 24i. Plus 10 I minus 15 I squared. Yay? Would you believe me if I say this is 16 minus 14i plus 15, because I squared is negative 1. So it just changes a minus 15 to a plus 15. Hey!
You add
Yeah, well, this. Oh, yes! Yes! Very good, Miss Caitlin. Yeah, the 15 and 16 are my two reals. So it's really just 31. Oh my gosh! This is so easy though! Right? Oh, yes. The F word! Sweet! Okay. Okay. Remember that. Remember that I is a radical. So you are not allowed to have radicals in the denominator.
Okay, does that
Right.
mean like you have to do the thing where it's
Okay.
2 like top, and then
Not necessarily just 2I. How about just I?
so
Because the I is the radical, not the 2.
so would that mean like it would be 3I plus 7I squared?
Yes!
Make it 3I minus 7.
Exactly. Exactly. Did you follow? No. Okay. So it started out with do we multiply top and bottom by 2I squared? And I said why? Can, but 2 is not the radical. What's the radical? The I. The I. So to get rid of the radical, you multiply both top and bottom by I. So the bottom becomes 2I squared. Yeah.
So you
And the top part, yes, here we go. And the top part becomes 3I plus I squared. All right. Here we go. Negative 7,
So would you have to do
negative 2. Right? Negative 2. No, not necessarily. Okay? You can leave it like this, or if you don't like negatives, you can change all of the signs by dividing negative 1 from both top and bottom. So another way you can do this becomes a positive 7. Take away minus 3I over 2. Either one I would take. All I did was take out a negative 1, GCF negative 1 from top and bottom and cancel it. Yay? All right. All right. What? Oh no. This is different. Why? There's more numbers and there's a minus. There's a minus. Okay. Here we go. Once upon a time, there was a little thing called dose. Right? Dose says that A plus B times A minus B. Hello? Oh, B. Did we skip 14? Boogers! Once upon a time, there was a little thing called dose. Dose says that A plus B times A minus B is equal to A minus B squared. Oh my gosh. Right. Here we go. This is a very, 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 very special thing for this thing, because A plus B and A minus B are called conjugates. Repeat after me, conjugates. Yeah. Yeah. They're like conjoined twins, right? Yeah. Okay. Here we go. So if you can multiply the bottom by its conjugate, then all you do is square the A and B at the bottom, and then you've simplified it. Let's do it again. Here we go. If you multiply the denominator by the conjugate, then all you do is square both sides of the denominator. Excellent. Excellent. Here we go. If this one is 2 minus 4I, then the conjugate would be 2 plus 4I. 2 plus 4I. There you go. Yeah. Both! Whatever you do to the bottom, you do to the top. But the bottom is the one you want to separate, right? So the conjugate of 2 minus 4I is 2 plus 4I. And of course, do that to the top and bottom. I'll worry about the top in just a second. Okay? But the bottom is where the magic happens. Because what's my A? Oh my gosh. What's the A?
4.
Right, because it's going to be 2 actually is what it is the A, right? So it's just 2 squared minus 4I squared is what happens to the bottom. When you do the conjugate, that's how you get rid of the I. It's because it squares it out.
So it would be like 4 minus 4.
4 minus, what's 4 squared? 16, right?
Oh.
But this is a negative 16, so it's going to be 4 plus 16. We'll see. We'll see. Hang on. Too much. Okay, here we go. At the top, you do have to FOIL. So 3I times 2 is 6I, plus 3I times 4 is 12I squared.
So it
There
would be
you go.
6I minus.
There you go. Here we go. So you have 6I minus 12 over 2 squared is 4 minus 16I squared
So with the I squared, it like cancels it out.
cancels this. So this becomes, do you mind if I go ahead and switch the 12 and the 6?
Yeah, go ahead.
Okay. Oh, thank you. Thank you. Here we go. So this is negative 12 plus 6I. And then this becomes plus negative 16. So this would be 4 plus 16. Sorry about that. It becomes a negative to negative positive, so it's 4 plus 16. So that makes it 20. 20. Yes. You can reduce. What's the GCF? Right? GCF is 2. So divide everything by 2. Final answer?
96 plus
Woo! That's it. That's it.
Wow.
GCF is 2. That's good.
I don't think I like
All right. Should we go back?
it.
Oh goodness.
So
All right.
Excellent.
You worried? Don't worry. Don't worry.
But you have to do the same thing.
Yes. But the question is, which conjugate are you taking, the numerators or the denominators? Why?
It's a dual.
I don't know.
Because you can't have what in a denominator?
Oh, the radical.
The radical. And what's the radical in this case?
Yeah.
The I. The I. So
Okay.
it's the denominator that gets the conjugate. Yeah? Not the top one. So the conjugate of 2 minus 4I is?
2 plus 3.
Yeah. Whatever you do to the bottom is the same thing on top. So you're not taking the conjugate of 2I plus 5. Don't do it. It's okay. Right? It's okay to have an I up there. So 2 plus 4I goes to the top. Yeah? Okay. Here we go. The bottom is a squared minus b squared. So 2 squared minus 4I squared, which we just did. No problem. All right. Here we go. The top, just FOIL it out. So 2I times 2, 4I. 2I times 4I, 8I squared. 5 times 2, 10. 5 times 4, 20. No, just I. I think it's just 20I. Yeah. Okay. We know 8I squared is just negative 8. So we know that's negative 8. At the top, negative, and then 4I squared is going to be negative 16. Right? I was just simplifying the I squares. What's up? Negative times negative would be positive 16. Okay? So just cleaning this up, the real numbers are negative 8 and 10. So 2 plus 4I over, this is 4 minus negative 16. 20. What is the GCF? 2. So 1 plus over, and they all lived. happily ever after. All right, my dears, you just endured a 2-day lesson in like 20 minutes. So excellent, excellent, excellent. Let me pause this real quick. Looking at a shift of the mother functions of sine and cosine. All right. Yeah. Here we go. What? It did? You know what?